Welcome to today's Econolastic video. I am Andrew.
And I am Joe.
And in this one, we're going to be covering the aggregate demand curve, and we're also going to have a bit of a focus on how the GDP deflator is calculated.
First, though, we'll remind you the basic relationship between aggregate demand and aggregate supply. So, the level of prices in an economy is determined by the interaction between aggregate demand and aggregate supply.
So you'll probably notice from this video and our next couple of videos that the analysis for aggregate demand, so in terms of a macroeconomic picture, will be somewhat similar to that for individual markets, so for a microeconomic picture, but you will notice some clear differences as we go on throughout these videos.
So Andrew has now drawn a simple AD and AS graph. So similar to the demand and supply for individual goods, price is plotted on the vertical axis, the y-axis.
However, as this is a macroeconomic analysis, this is the general price level in the economy, which can also be referred to as the GDP deflator.
So the GDP deflator measures the change in prices of all the goods and services produced in an economy.
So in other words, it shows the effect of price changes on GDP. And it does this first by establishing a base year and then comparing prices from another year to prices in that base year.
On the x-axis then, we plot quantity, but on a macro scale, this measures the national income, which is GDP.
So this is where we're going to go a little bit into the GDP deflator, and the calculation for that is as follows. So the calculation is the GDP price deflator is equal to, on top, nominal GDP over, on the bottom, real GDP times 100. So in the base year, whatever year you choose that to be, the Federal Reserve Economic Data, the FRED in America, they use 2012. The GDP price deflator will always be 100.
This is because the nominal GDP and the real GDP have to be the same figure in the base year. To work out the price level difference between any year and the base year, you first need to work out the GDP deflator for the year that you want to calculate.
So using figures for 2020 that we derived from the FRED, the GDP price deflator for 2020 will be as follows. The nominal GDP is $20,934.850 billion. And then the real GDP is roughly $18,500 billion. We do that times 100 and we get a figure of 113.68. And what this tells us is that the price level in 2020 is approximately 13.68% higher than the base year of 2012.
Let's take another year, for example, and we've chosen 2010 in this case.
So in 2010, the nominal GDP is just under $15,000 billion. And then the real GDP in 2012 dollars, 2012 being our base year as defined by the FRED, that is around $15,500 billion. We times this by 100 and we get a figure of 96.11.
The figure below 100 means the price level in 2010 is roughly 4% lower than it is in the base year of 2012.
4% because it's only just over 96, but to do it accurately, it's about, 3.89% lower. So we're taking you through the process if you have a defined base year. What's the process if you want to compare two price levels between 2 years, neither of which are your base year? Well, we're going to take you through that now. So the basis of the calculation is much the same. You still have to do this calculation for 2 years, the 2 years that you're trying to compare against, and then you'll have one extra calculation, which we're going to come along to.
So we'd first find out the GDP deflator for each year, So using the numbers we've already produced, which is the 2010 number, which is 96.11, and the 2020 number, which is 113.68.
So Joe's just reminded us of the GDP deflator for 2010 and 2020. So the price level change is equal to the GDP deflator in 2020 minus the GDP deflator for 2010 all over the GDP deflator for 2010 times 100 right at the very end. I couldn't quite fit on the whiteboard.
So taking what Andrew's just said, we'll put the numbers in. So it's 113.68 minus 96.11 over 96.11 times 100. This equals 18.2.
And what that means, of course, is that the price level in 2020 is 18.2% higher. We'll add a little percent there. It's 18.2% higher than the price level in 2010.
So we'll return to the aggregate demand curve. So the aggregate demand measures the total level of spending in the economy.
It does.
Yes, it does. This consists of four elements: consumer spending, which is denoted by C, private investment, which is denoted by I, government expenditure on goods and services, which is denoted by G, and expenditure on exports minus expenditure on imports, and the exports are denoted by an X, and the imports are denoted by an M. So aggregate demand is equal to C plus I plus G plus brackets X minus M.
There you have it. So aggregate demand is quantified by this equation right here. Therefore, the aggregate demand curve shows what quantity of national output, or GDP, will be demanded at each price level. So this was a very short video really on aggregate demand because we covered the GDP deflator in there as well. In our next video, we're going to be covering why the AD curve slopes downwards, and this is generally caused by the income and substitution effects. So there's going to be a video solely on those two.
Following that, we'll conclude this three-part mini-series with movements and shifts of the aggregate demand curve. Thanks for watching our Econolastic videos. Please check out our other YouTube videos on a range of economic topics. Don't forget to like and subscribe to the channel.
Please also check out our website at econolastic.com. The link will be in the description for you. This is where you'll find our step-by-step dissertation writing guide, which is suitable not just for economics, but for a whole host of degree subjects. And it's where you can also book us personally for 2-to-1 tutoring sessions.
See you in the next video.